much for coming. I really appreciate it. My name's Ian Bateman, and the slides have already moved on. That's interesting. Okay. Sorry about that. I'm going to introduce the speakers, but first of all, I want to just say a few words, just trying to frame what we're trying to do here today. Because it's Nature Day here at COP26, we're going to be talking about the issue of planting trees, but really what we're focusing on is a much wider issue, and that is the need to address an integrated problem like climate change in an integrated way by bringing different disciplines together. So, is that okay? That's grand. So we have two integrated systems. Now, systems, what do we mean by systems? I just mean an entity, that's going from one buzzword to another, where if you push one aspect of this system, another aspect bulges out. Okay, so for example, you plant trees in one area, then you're going to affect the amount of agriculture and production over the whole country. These are two systems joined together. The environment is this complex mass, and the economy is, again, a connection of many actors, many different businesses, governments, that sort of stuff. And again, when you push one side, about the challenges that we've got. We've got interconnected challenges. The climate challenge of a world which, because of greenhouse gas emissions, is getting warmer, is also linked to the challenge of biodiversity loss. And we need to address these together because in the real world, they really are linked. If we just address one, we're not going to be looking at the other. We need to look at the two at the same time. Because, as we already know, we have induced a level of climate change, which means that many people would say we're actually saying farewell to the world that we know, and instead moving to a new world, the Anthropocene. A world where, yes, we have a thriving economy, but it has been bought at the cost of environmental damage. And so we're seeing problems like climate change, biodiversity loss, and all the others that you can see here as a result of not making these integrated decisions. These integrated decisions need integrated responses. We need interdisciplinarity, and that's what we're going to be presenting today through an initial talk from Professor Richard Betts of the University of Exeter and the Met Office, and he's going to be laying down the basic science which is needed to understand the risks from climate change. We're then going to hear from Alice Larkin, Professor Alice Larkin from the University of Manchester, who's going to be talking about the challenge of the dwindling carbon budget that we have in the world now. We're then going to have Dr. Gwere Jones, who is going to broaden this out and bring in the issue that while we're delivering net zero, we also need to consider the biodiversity challenge. And then I'm going to try and bring this together and show how we can take these various strands of integrated science and bring them into real-world decision-making within business and government. Okay, so we're going to move on straight away, and I'm going to invite Professor Richard Betts to come and give the first talk. Okay, Rich, over to you.
Thanks, Ian. Yeah, thanks very much for the invitation to join this workshop. I'm really looking forward to the talks and the discussion, actually. So a really multidisciplinary perspective, hopefully, I think. So I'm looking forward to that. So as Ian said, my role here is to give the background from the climate science perspective, and there's two reasons for that. One is to remind us all of the kind of changes that we are trying to avoid by taking action on climate change, primarily by reducing emissions, but also by removing carbon from the atmosphere actively as well. The other perspective is reminding us of what climate change is already committed to or already happening, which we therefore need to adapt to and be resilient to in anything we do, including any of these mitigation actions. So there's two aspects to it there. Some of this draws on the work we did for the third climate change risk assessment. I led the technical report which underpinned that, and that was published along with the Climate Change Committee's advice report in the summer. So that was independent from government. It was an assessment of how well the UK is adapted to climate change and the risks that we face, and the government, particularly DEFRA, will respond to that in terms of what the plan will be and informing the national adaptation plan. Some of this work will also draw on work that's been published in the IPCC reports. I'm a lead author on the current report, and also some work that we did for a major EU-funded project called Helix, which stands for High-End Climate Impacts and Extremes, so a big international programme both across Europe and also Africa and South Asia. So a wide range of information sources here. So the first point to make is that the world is warming, and it is our fault. The conclusion of the most recent IPCC report was that we are certain that we have caused this warming of the world. The graph on the left there, that's Met Office data, so it's the change in annual average temperature globally every year from 1860 up to last year. So each bar is a single year. The blue bar's going down. It's cooler than the average in the end of the 19th century. The red bars are warmer than average, and you can see that we've warmed the world by over 1 degree Celsius over the last century by putting more carbon dioxide and other greenhouse gases into the atmosphere. And we are now able to see the effect that this is having on extreme weather around the world, not only in the UK but everywhere else in the world as well. Many types of extreme weather events are becoming more severe or more likely. So two examples just from this year. So that the hot summer in Europe this year recently announced just last week here at COP. My Met Office colleague Nikos Christidis led this work, which showed that temperatures of that level this summer would have been virtually impossible without human influence on climate change. It would have happened perhaps once in 1,000 years or something, and now it's happening, and much more likely. Similarly, we had slightly earlier in the year, or around the same time, we had dreadful flooding in Western Europe, which led to many deaths, unusually for Europe. Over 200 people died due to severe flooding, and again, that has been calculated to have been made more severe by climate change. There's a group called World Weather Attribution, which routinely make these calculations within days of an event happening to show how much more severe or how much more likely they have been, and the rainfall was increased by more than 19%, up to 19% because of climate change. I want to mention that the one of the people that founded this, Geert-Jan van Oldenburg, sadly passed away only a few weeks ago. So I just wanted to briefly pay tribute to the amazing work that he has pioneered in this, because this is such an amazing and useful piece of scientific methodology which is now being applied. So we are seeing extreme weather events happening around the world due to more often and more severely due to climate change. So that's the same graph that I just showed earlier, but squeezed down because I'm making room for the future projections. So it's again annual temperature changes. Now what we are aiming to achieve under the Paris Agreement, the international community has signed up to keeping global warming well below 2 degrees above pre-industrial, pursuing efforts to limit warming to 1.5 degrees above pre-industrial. But you can see how close we are already. Recent years have been like 1.2, 1.1 degrees Celsius above pre-industrial. So we're approaching 1.5 degrees global warming, and in fact there's a fair chance that an individual year will pass 1.5 degrees warming, possibly within the next few years, to be honest. So the target is more about the long-term change, but even so, we're getting very, very close to that. So when we're looking at risk assessments, there's many different scenarios you could be preparing for. When we run our computer climate models, which are the same as the Metaverse weather forecast models, essentially the same calculations, but you carry on going for 100 years into the future or more, adding in more greenhouse gases and so on. There's many different outcomes you could look at, a whole range of possibilities depending on what the emissions do in the future and how the climate responds. So often what you see is a simplification of the whole range of possibilities. I'm just showing one particular outcome, but this is how that graph of observed temperatures may look by the end of the century in a scenario which just about meets the Paris target of limiting warming to below 2 degrees. But we're not anywhere near on track for that in terms of actual action on the ground. We've had lots of pledges this week already, which is great news in terms of promises of reducing emissions. But if you see happening on the ground, so what is implemented in energy policy and transport and so on, as opposed to what's promised, we're still on track for much more warming in terms of what's actually implemented. So currently implemented policies, it's estimated with the central estimate would give us warming of around about 3 degrees Celsius, perhaps a bit lower relative to pre-industrial, but it could be anywhere between about 2 degrees and 4 degrees or even more, depending on the sensitivity of the climate system, what kind of feedbacks might kick in, how much carbon might be released from the biosphere, from forest fires and so on, or a reduced uptake by the ocean, for example. So we can't really narrow down exactly where we're headed. So when we do climate change risk assessments, rather than looking at the central estimate of where we're heading, we look at a higher end scenario. So we tend to look at a world which is reaching 4 degrees global warming by the end of the century, which is not the most likely outcome under the current trajectory, but it certainly can't be ruled out. So for risk assessment purposes, and we're still actively considering the implications of that kind of change. So I'll show some results of what a 4 degree world could look like, and in some cases how that compares with a 2 degree or even 1.5 degree world. So first of all, looking globally, the most obvious risk of a warming world is it just getting too hot for people. And one of the well-used measures for heat stress is this thing called wet bulb globe temperature, which is a combination of temperature and humidity. So when it's humid, you can't cool your body by sweating, so you have much more risk of heat stress. And 32 degrees Celsius wet bulb globe temperature is an industry standard measure for extreme risk of heat stress, where outdoor working tends to be prohibited if you're in the military or in the building industry or whatever, if your country implements these regulations. So those kind of temperatures occur occasionally under the current climate. This year in Pakistan, for example, there have been some really dreadful heat stress incidences, but at the global perspective, that's still fairly localised and infrequent. But at 2 degrees global warming, the map on the left there shows how often those kind of temperatures might be seen across certain parts of the world. So we might see perhaps over 1 billion people exposed to these kind of levels of extreme heat stress risk for more than 10 days a year at 2 degrees global warming, particularly in the Indian subcontinent, which is very hot and humid and also highly populated, but also parts of North Africa as well. But then if we do reach 4 degrees global warming, then basically the whole of the tropics would be seeing those kind of heat stress levels on a regular basis, in many places for much of the summer, 2 or 3 months or so. So there really is a severe risk to perhaps over 3 billion people at high levels of global warming from that. And that would essentially mean that outdoor working is impossible when you get those kind of levels of heat and humidity, and you'd have to be living inside in air conditioning. We're changing the water cycle, of course, as well. And I've put a map of the changes in drought. It's more complex than the changes in temperature, because some areas are getting wetter, some areas are getting drier, depending on changes in rainfall patterns. But it's not only rainfall patterns that matter, it's also evaporation. And again, under a higher temperature conditions, you get more evaporation from the landscape. The landscape is dried out, and that can increase the hydrological and the agricultural drought, drying out the landscape. So large parts of the world would see a greater extent of the year under extreme hydrological drought, although some areas would see less time. It's important to note you get different answers from different climate models with this kind of this kind of study. So it's hard to say exactly what will happen in each place. But there's some areas we're confident, like most of the models will do suggest a drying in South America, for example. All the models suggest a drying in the Mediterranean region, North Africa, and the Iberian Peninsula. But also, even though many areas are drying, a great many areas would also be at increased risk of flooding, and that can be kind of counterintuitive, because the same place can be both at increased risk of drought and increased risk of heavy rain and flooding, because you get the time between the rainfall can be drier because of evaporation, but when it rains harder under a hotter climate. So most countries in the world are projected to have an increase in flood risk from heavy rain and river flooding, and this quantifies that for a scenario of 4 degrees global warming. Currently, about 50 million people per year are affected by river flooding. That would increase by 4 times or more to over 200 million at 4 degrees global warming. But the other risk of flooding, of course, comes from rising sea levels. So the ice on land is melting, both in glaciers and some parts of the ice sheets, which puts more water into the oceans. The oceans themselves expand as they warm. Just water expands when it's warming up. So both of those are already causing the sea levels to rise. And these two scenarios show what the global average sea level rise would look like if we reached 2 degrees warming by the end of the century and 4 degrees warming by the end of the century. So the 2 degree scenario, which, as I mentioned, would be within the realms of meeting the terms of the Paris Agreement, could easily mean around about half a metre of sea level rise by the end of the century. So that could be a best case scenario, potentially, if we're meeting international targets. If we fail to meet these targets and then we do reach 4 degrees warming, then it could be almost up to a metre, but well over a half a metre anyway, by the end of the century, which would impact huge areas of coastline around the world, and I'll show an example in a minute. But it's important to note that both those lines are still trending upwards by the end of the century, and if you just extrapolate those, if you assume that that level of trajectory of warming continues, then you can see that the even more sea level rise is in the pipeline beyond the end of this century. And many countries, low-lying states and small islands, are concerned not only within this century but the next century and beyond. So well over a metre is possible in the longer term, even if it doesn't happen this century. So one particular example I wanted to show on this was on Bangladesh, which is, of course, is a very low-lying country. Some colleagues of mine who in Bangladesh, in the Helix project which I mentioned earlier, they looked at the impacts of Cyclone Sidr, which occurred in 2007, which affected about 1% of the country and 2 million people. That was the actual cyclone, but they imagined what would happen, or they modelled what would happen if the same cyclone happened again with half a metre of sea level rise, and that would double the impact, basically. So it would have affected 4 million people if the sea level had risen by half a metre. If with 1 metre sea level rise, it would be impacting up to 7 million people, and if sea level rise reaches 1.5 metres, the impact would be 9 million people and flooding nearly 6% of the country. So those kind of cyclones do happen. Their impact will be much greater if and when sea level has risen. And just for a couple of examples of places like Australia, California, and so on. But under a warmer world, the extent of time with higher fire risk of fire weather, which is a combination of dry conditions, high temperatures and high winds, that would increase quite substantially, to some extent under a 2 degree warming world, and even more under a 4 degree warming world. So we'd have to be bearing these in mind when we're planning adaptation and especially what we're doing with the natural environment in the UK in the future. And finally, though, just to make the point about, as I mentioned earlier, that we are still quite uncertain in the exact conditions that we would see. So this figure shows a time series of the projected changes in precipitation, so rainfall and snowfall in the UK in the summer season, from the most recent UK climate projections, UK CP18, produced by the Met Office, for a scenario, an emissions scenario, which is kind of at the medium-high end. So it's not the most extreme scenario. And the width of the bands, the percentile bands, show the range of outcomes and the distribution of outcomes from a very, very large set of climate projections. And although it's trending downwards, the rainfall precipitation prediction is trending downwards, there's still some which could see an increase in rainfall at the 75th percentile level or above by the end of the century. So still a 25% chance of being higher rainfall in the summer, even though it's a 75% chance of lower rainfall. So you have to kind of hedge your bets to some extent when you're planning to deal with these. So just to summarise then, risks from climate change are already increasing and severe impacts are projected. We're aiming to limit warming to between 1.5 and 2 degrees global warming. So we'll need to adapt to that. That's the minimum that will change. But up to 4 degrees warming, or possibly a bit more this century, is still possible with the policies that are currently implemented. But the risk will be limited if we can minimise the level of warming going forward. And I hope we can discuss this later on, but using planting trees as climate mitigation, we need to bear in mind that will take place in the context of this uncertainty in future regional climates. So we have to be very careful about what we're doing when we're making these planning decisions, particularly bearing in mind the uncertainty in future changes in precipitation. I'll finish there. Thank you.
Hold on for a sec. So what we're going to do with regard to questions, hold on, Rich, I'm going to keep you up for a sec. We're going to just start off with just one or two questions specifically to Rich. The main opportunity that you'll have to pose questions is going to be after all four talks are concluded. So are any immediate questions just for Rich? Yes, please, would you like to...
Thank you. So the question is about sea level rise, and so I was just looking at the figures that you showed there, and I've been to it's not something I know anything about, but it's something I've been to a number of talks on over the last week from people talking about things like the fact that dynamic ice sheets are not in modelling, and therefore that potentially they might expect to see a metre or substantially more sea level rise this century. So I guess I just wanted to ask. You should kind of comment on that, and I guess more broadly on the sort of these perhaps low likelihood but super high impact scenarios, and whether you think those are something we understand well enough and communicate well enough. And
yeah, thank you for pointing that out. That's great. So some of the dynamic ice sheet modelling is included in these projections, but it can't account for everything. Because there's still a lot of things that aren't fully understood, like collapse of marine ice cliffs, so the actual kind of breakup around the borders of the ice sheets and so on. So there's still a whole range of possibilities, and the story on that it changes quite a lot, almost kind of month by month as new research comes out. So I probably should have put a kind of wider error bar on that figure, to be honest, to account for these possibilities of these things that aren't fully understood. The IPCC report did consider higher levels in a kind of low probability but high impact kind of way, kind of worst case scenario. So yeah, it probably is worth bearing in mind that there's possibly worse things there, which I didn't include in that figure. Thank you. Yeah.
I think we've got time for just one more question. By the way, you can ask questions through the YouTube channel.
Yeah, but perhaps to ask the question in a slightly different way, in terms of the feedback loops, specifically on ice sheets melting, polar ice caps and so forth, what is the sort of the medium to high case? I think you talked about the figure I've heard most consistently is 2.7. So maybe you can just elaborate a little bit on that 2.7. Does that incorporate feedback loops or not? And if it does, what are the feedback loops that are incorporated?
Thank you. Yeah, another really, really great question, which it's important to discuss. The 2.7 warming, which you've heard, that figure is kind of a central estimate of where we'd be heading based on emissions from what's considered to be a continuation of currently implemented policies. But translating that into the range of outcomes of warming, as I mentioned at the start of the talk, there's a huge range of uncertainties, including the feedback loops. So there's one of the uncertainties is responses of cloud cover. There's a metric called climate sensitivity, which climate scientists have been trying to sort of nail down for many decades, and finally in the last year, the uncertainty in that was reduced quite a bit. But then there's feedbacks from the carbon cycle. So forest fires, a reduction in uptake of carbon in ecosystems, release of carbon from the soils, perhaps from oceans, from permafrost areas and so on. Many of those are now included in models, but we can't constrain them very well. So that's hence the wide range I showed in my figure earlier, which of the 4 degree or more warming. So when you're looking at these climate scenarios, you can get you can get 4 degrees warming through several routes. You can have a very high emissions scenario, but with an unresponsive climate. That's one way of getting there. Or you could have, if the climate is very responsive and has strong feedbacks in it, you could get to 4 degrees with a much lower emissions scenario if the feedbacks are strong in the carbon cycle, for example. So much of these are included in the models, but a lot of it, the understanding is still not perfect, a long way from being perfect. Yeah.
Okay. Thank you very much, Rich. I really appreciate you getting us off to such a good start. As I say, we're going to have a panel question and answer session at the end. And for those of you watching on YouTube, you can just ask questions via the comment box. So I'm now very pleased to introduce Professor Alice Larkin from the University of Manchester. And come on. Alice.
Thanks very much, Ian, and thank you very much for inviting me to talk to you about the dwindling carbon budget challenge. So I guess I'm talking about sort of a bit of a caution, really, around and the risks around some of the broader issues to do with carbon dioxide removal and negative emission technologies. So I'll just run through a little bit of that and some of the carbon budget background and a little bit about where we are, how we've been doing, that kind of thing. So I work at the Tyndall Centre for Climate Change Research. It's an interdisciplinary research group. So whilst I originally started my journey in physics and climate modelling, we were talking earlier about the huge importance of having the different disciplines coming together to understand the problem, because the problem isn't one of science and isn't one of engineering. It's one of all disciplines. These real world challenge problems, and so I'll just give a little bit of the jigsaw, and I'm sure we're going to hear more about some of the other aspects that we really need to consider. So I'm going to talk a little bit first. I just want to remind us about our influence. The influence that we have had and the influence that we can have, and not to forget about that in relation to these rising greenhouse gas emissions and then the outcomes that Richard's just been talking about. The scale of this challenge and some progress, perhaps, or not, some gaps, and a question around, some of the potentially miracle fixes. So our influence, just a reminder, we can choose our future. Many of us will be from wealthier parts of the world or the wealthy in poorer parts of the world. And where that's the case, our per capita emissions are going to be higher than the global average. If we're in that situation, it means that we have some choices, we have some influence, and it means that we as individuals or as societies, as communities, but also in how we influence perhaps the decision makers, can have some influence. But that also means that we are influencing others' futures as well, other people who don't have that influence over emissions, because per capita emissions in some countries, on average, and some people in some countries are going to be significantly lower. And I think that this should be not a depressing thought, but a powerful and an important positive thought that, you know, we have had a huge influence on our climate, as we've already been hearing. And that means that we can have an influence on our future and the future of others. And I think that that's a really important thing to keep in our minds. Now, just speaking of that influence, here I've got a graph of the fossil fuel emissions from fossil fuels and industry. That's up the left-hand side there. We've got time going from 1750, so from pre-industrial revolution all the way out to very near the present day. And this is just to give you a sense of what our influence has been. So this graph here is just simply illustrating the fossil fuel CO2 emissions that we have put into our atmosphere as a result of the development and the industrialization and all the kind of positive things that have come from that. But the fact that they have been associated with the CO2 and other greenhouse gases that we've been putting into our atmosphere. Now, you'll also see that there have been some little blips along the way, and some of these are associated with global economic downturns, recessions and so on, because it still is the case that our greenhouse gas emissions, particularly CO2, is very closely related to our economy. So it's also no surprise that the little dip at the end there, that is the dip associated with COVID-19 in that particular year. And I'll also talk a little bit about where the latest data that was released a few days ago is got us to now in terms of emissions. But we have had an influence on emissions, and so we can have an influence on bringing those down. And I think that's just really important just to recognise. So moving on to the scale of the challenge, that was set basically in Paris in 2015 by the COP meeting at that time. And that tells us, as we've already heard, that we need to hold global average temperatures to well below 2 degrees centigrade. We need to pursue the avoiding a 1.5 degree. And of course, 1.5 degrees now is getting much, much more attention, and rightly so, in terms of the impacts that even happen at that level of climate change, let alone at 2 degrees, as we've been hearing. And then we need to make rapid reductions in our greenhouse gas emissions in accordance with the best science and on the basis of equity. Now, I'm not going to get a chance to talk too much about that aspect of it here, but this has big implications for different kinds of countries at different stages of development, and the responsibility of those countries in terms of their emissions and bringing them down, because, of course, the impacts tend to be felt by places that haven't created the problem in the first place. And so there's a big challenge there in relation to equity and the economy. So if you look then at the kinds of emission trajectories that we're talking about to avoid a 1.5 degrees, here again I've got the emissions of carbon dioxide up the left-hand side. The orange line there sort of indicates where we are in 2021. This is just taken from the latest 6th assessment report from the IPCC and illustrates some of what Rich was sort of highlighting, that, you know, there are a number of different scenarios, some of which lead to very significant climate outcomes and climate and temperature rises. But if we want to kind of focus on the 1.5 degree, then we're talking about this lower blue line here. And actually, you'll see that there is a zero line to this graph, and this is where the emissions are passing through zero and going negative. So this net zero term that you'll hear all over the place, there we see the point at which that goes through net zero, that 0 point there. And that has to happen in order to avoid the rise of 1.5 degrees. Now, I just want to try to talk through that a little bit, just to illustrate why this has become such an important part of the debate, this net zero point, but also some of perhaps the risks associated with that, and how that connects with some of the land use aspects that we're going to be hearing more about shortly. So on this graph, again, I like my graphs, I'm sorry about this, it's because I originally was a physicist, not anymore. So the left-hand side, global CO2 equivalent emissions, so greenhouse gas emissions up the left-hand side, time, 2010, out to 2100 along the bottom. Now, the green area there is our gross CO2 emissions, so that's just the CO2 aspect of it, or part of it. The pink is the other non-CO2 greenhouse gases, and so altogether the total greenhouse gases will be touched by that top amount there, so all that area above the curve. What we've also got is this purple amount down here underneath the curve, so these negative emissions underneath here. And so together with the emissions that we're putting out and the emissions that we're taking out, together, that will give you the climate outcome. So it's about the emissions that we're releasing and also the emissions that we're removing, the emission removals. So, as I say, your net zero CO2 emissions is where your orange dotted line passes through, and this on this particular graph, which is taken from the United Nations emissions gap report that's just come out. So this is just a stylized version of that. Have it, passing through net zero CO2 around 2050, and similarly, we have a net zero greenhouse gas emission point as well, depending on what the expectation is that most of the removals will be CO2 removals, not the other greenhouse gases. And so this is called our net negative greenhouse gas emission amount under here. So what's all this important? Why is that important? Why do we need net negative emissions? Well, one argument is that some sectors are going to find it so difficult to reduce their emissions in that sort of time frame that we need to find ways to go below zero from other sectors. And the kinds of sectors that come into that debate are things like aviation and shipping, which are two areas that I work on. Now, I would argue that they are not difficult to mitigate in terms of technology for shipping. Aviation, there's a whole debate around demand, but they get classed as difficult to reduce, and therefore we need to go below zero. Again, that's another discussion for another day. Other sectors, so industrial emissions, some of the emissions associated with processes that are really difficult to remove, and then really significantly agriculture. So the N2O emissions associated with agriculture for feeding, a growing and population and a developing population. N2O emissions are a really important part of this picture, going to be incredibly challenging to reduce to below zero. So again, we need to think about what is it that's going to be able to keep us on track for 1.5 degrees. But my word of caution is, what if the negative emissions do not materialise at scale? And this is drawn from some research that I've done with my colleagues at the Tyndall Centre, just asking that question really, what if we don't manage to go below zero, and what are the implications of that? So, on to progress, gaps and miracle fixes. According to the latest science, there's about a 50-50 chance of exceeding 1.5 degrees in the next couple of decades. This is just from the United Nations GATT report. And without immediate, rapid and large-scale reductions in greenhouse gases, limiting warming to even 2 degrees by 2100 is going to be beyond reach. So we are really at this crucial point in terms of what needs to be done, and I hope that the COP meeting, I only arrived yesterday, but has that sense of urgency about it, because this really is a very urgent problem. And we've already heard pre-COP, the pledges that were being made were setting us on track for 2.7 degrees C. Of course, there's lots of optimistic and hopeful assumptions that are embedded in those pledges as well, and we need to keep those in mind. So if we go back to my graph to help us see, understand the problem, if you imagine my hypothesis that we don't get all those removals that we wanted to, and I'm just going to remove them all, just for argument's sake, just to kind of get across the science of this and try and help us understand it. It's actually the area under this curve that is what we need to focus on. That's what gives us our climate outcome. That's why if we go below zero, that buys us some time, if you like, in terms of how quickly we need to reduce emissions. But it's the emissions associated with the area under that curve that lead to the amount of climate change that we experience. Now, there's lots behind the various carbon budgets. There's lots of different ways of interpreting them, partly to do with the different percentage of 1.5 or 2 degrees and so on. Some of the feedback situations and Earth system feedbacks that have or haven't been fed into this. But just for sort of illustrative purposes, and this gives us a sense of scale, I think. About a 50-50 chance of 1.5 degrees leaves a carbon budget for your energy of around 335 gigatons of carbon from 2022. Now, if fossil fuel and industry CO2 emissions plateau at the kinds of levels that they are now, and I will tell you in a minute what's happened in the latest data if you haven't already heard about it, that gives us just 10 years at the levels that they're at now with our remaining carbon budget. And this is where you get to this issue of urgency. Or you could have a scenario where, well, let's assume that we have a COVID year reductions for a couple more years, so that they reduce by about 5% the CO2 from fossil fuel and industry. Now, if we could actually implement that positively, rather than just it's something that's happened because of a global pandemic, very challenging, and all the consequences that has come with that, and then we try to ramp up those emission reductions with the kinds of policies that would lead us to 10% per year, which nobody is talking about at the moment because that is incredibly challenging to achieve. But even if you did that, you would still need to get your emissions to get to zero by 2045. So that's just to give you a bit of a sense of that scale. I've tried to illustrate it back on the same graph. So sorry if this is a little bit small, but because I wanted to keep the same graph, the same time frame, just to illustrate it. It's the area under this curve that matters. The little blip down and up, what you can see at the top there, that's our COVID year, and then the little bounce back that I'll give you the figure for shortly. And this is just that imagining it really significantly reducing. If we don't manage to go below zero, that's what we would have to do in order to avoid your 1.5 degrees. So this assumes your no carbon removals or negative emission technologies. So in other words, no reforestation or land use change that would actually remove CO2, but it also assumes no technologies such as biomass with carbon capture and storage, direct air capture, those sorts of technologies which are also assumed in many of the models. So the reason, just to highlight the importance of this area under the curve, if we don't manage to start to reduce emissions in the very near term and we happen to increase our emissions, they start to continue to grow again because of a revival in the economy, which is what we're hearing quite a lot of at the moment. The outcome of that is that whatever they overshoot our little emission curve by, in terms of this purple area here, has to be made up for later or has to be removed from our atmosphere. And there are a couple of policy implications that is the bit that I guess my research focuses on, is what are the policy decisions and the different difficult decisions that need to be made in the short to medium term to actually get us off this 1.5 degree trajectory. And firstly, our steepness of the trajectory, it changes depending on how well we do. So if we're not doing very well and we're not reducing emissions, then we need to start ramping up the action further down the line. Now, if you're actually putting in policies to do that, that means that the policies have to be more stringent, more difficult, and probably are less palatable. So the sooner you start, the more palatable they can be. And you're also going to change your 2050 type of target, because you've got a moving feast, if you like. And we often focus on 2050 because it's a nice, neat number. People talk about net zero 2050. I would just caution against that, and just this focus on 2030 that, I know has been a big conversation at the COP meeting. Hugely important. It's the pathway, it's the area under the curve, it's what you do in the near term that really, really matters. And so this short-term focus is really key. So the question then, though, is, that's an incredibly challenging picture. How far, how quickly could we get below zero to help, and what if we don't? And I'm not going to answer that question because I know there are other experts in the room that can answer that. Latest from the Global Carbon Project, we had a big bounce back of emissions in this year. This is estimated at the moment for 2021, for plus 5% or 4.9% is what's expected. So we aren't on that downward trajectory yet. We're spending our budget too rapidly, so betting on nets and removals to work at scale. That's what we're doing. That's what we're assuming is going to work and going to get us out of this challenge. What's the risk of this strategy? And it's just a bit of a provocation here. So I would say that the risk is that assumptions about negative emission technologies and removals can potentially influence the choices and decisions, and it goes back to influence, that we make around mitigation policy. So this is pre-COVID, right? Just very quickly, this is me trying to have a virtual social interaction at a conference. I was on a Segway, I was remoting in from my office and trying to use virtual technology rather than fly to a conference, because I know that's a very carbon intensive thing to do. So are we, on the energy side, incentivizing some virtual alternatives at this point where we know, some of the things that we need to do to cut emissions, or, as has happened in the UK last week, are we reducing our tax on domestic aviation fuel? Now, I would just argue that there is a risk at the moment that we are relying on things that we want to work. We definitely want CO2 removals. We want negative emission technologies to work to be able to draw down greenhouse gas emissions. What we don't want to do is disincentivize the kind of energy mitigation policies that can deliver the change now. So just to conclude, 1.5 degrees requires near-term mitigation because carbon dioxide and the other greenhouse gases accumulate. 1.5 degree scenarios all assume large-scale removals and negative emission technologies, so we need to get a move on with those. Absolutely hugely important. But many, I don't know, we're going to hear more, might not work at scale. So we need to recognise and mitigate the risks of this strategy and make sure that we focus on where we can reduce emissions and we have known solutions. And then just a question really, is there a case for separate targets for the CO2 and other emissions associated with our energy system? And then the whole question and on opportunity around CO2 removals and greenhouse gas negative emission technologies. Thank you very much.
Thank you very much, Alice. We've got time for at least one or two questions. So, gentlemen here.
Sorry, one thing I wasn't absolutely clear about with respect to some of your great charts, very, very helpful charts, is obviously what we've heard over the last week are various targets from countries. Okay, we've heard targets of net zero for 2050 for a number of countries. India came out with 2070, China said 2060, and obviously they're the nearer term targets of 2030. Obviously some of this research was done way before that, but I just want to get I wasn't clear about how much of the latest numbers have been incorporated in your thought process.
Thanks very much for that question. Yeah, so the latest pledges that have been made since, the last week or so are not incorporated. And all, I suppose, in terms of the latest emission data, that's what's there. The kinds of pledges that are being made I know that there's been some analysis at the COP meeting around, is it 1.8 degrees, is it 1.9 degrees? I haven't analysed that yet, but what I would say is that will also include a lot of removals and a lot of negative emission technologies, because you have to make assumptions. So what the pledges do, they look at the 2030. Sometimes they might look a little bit longer, and so what you've got there is you can analyse up to that point, but the question is what happens after that. And actually that becomes more subjective at that point, because you have to make your own assumptions about, well, is that going to continue like this, or if it's a country that's made a pledge that's only just turning it over, is it going to go back up again? And so whilst there have been analysis, I think Meinhausen has done some analysis. I think I read recently that is just in the last few days is estimating 1.9 degrees. I would just say that, it's about the assumptions after the pledges that we also need to think about. And that's probably where the removals question also comes in, what are the assumptions around that? Thanks.
Thanks very much, Alice. My name is Frank Convery, and I've been working for a while now in Ireland on agriculture emissions and removal and so on. And I immediately perked up when you expressed skepticism about some of the negativity about options for marine and air. And I would say the same is very true of agriculture, because when you interrogate it, there's been zero effort, I would say, a tiny sliver of effort at innovation. There's been no narrow learning by doing. There's been no, hardly any serious research. And the ag lobby keeps saying we don't have any choices, and we don't have any choices because we haven't tried to have any choices. So you're in this loop of failure. And I really feel very strongly that if we put anything remotely like the effort we put into energy and renewables and so on into the land space, both on removals and on reductions, you could change it dramatically and quite quickly, I think. But there's this conventional wisdom that the choices are horrible.
Low emissions seem to be a huge challenge. And again, I haven't done work on this for a long time, but in terms of even, organic agricultural practice and other sort of ways in which you can treat the land better from a kind of biodiversity point of view would still lead to N2O emissions. So it did seem that was a particular challenge, and particularly because they are more long-lived than the methane emissions. But I am sure you're correct that there hasn't been the attention on agriculture in terms of that innovation. So hopefully we're going to hear more about that now.
Well, we've got one more talk to come first, but just a very quick comment back to that. I was told not long ago by, I won't say who it was, but official, and they said, farmers don't really pay any attention to subsidies for planting trees. And I said, well, that's because you pay them about 5% of what you pay them to not plant trees. The maths isn't that difficult. Okay, so thank you very much, Alice. That was a fabulous talk. I'm going to now introduce someone, first of all, from an organisation that is very close to my heart. When we think about dealing with integrated solutions, we also need to think about integrated policy. And the next speaker is from the Joint Nature Conservation Committee, JNCC, which is one of the few organisations that works across all 4 countries within the UK. And it's those sort of organisations that we need to have a coherent, integrated approach, certainly within the UK, to the joint challenges of climate change and biodiversity loss. So I'm very pleased to invite Dr. Gwere Jones to come and address us. Thank you.
I'm going to use the stand. That's okay. Oh. I don't know, can you hear me? Is that okay? Brilliant. Great, so thanks for the kind introduction to JNCC from Ian Bateman, but also thanks for the invitation to speak this afternoon. At the Joint Nature Conservation Committee, we do provide advice on practical policy-related evidence-based solutions to support decision-making. So we work on the science-policy interface. Usually, in my case, you'll notice my job title, I'm a remote sensing scientist. So I advise governments on the use of satellite imagery and how they can integrate that data into decision-making. But today I'm going to be talking mostly, I'm providing some insights on the policy challenges facing us on the road to delivering net zero from a biodiversity perspective. So if we look at the net zero strategy that the UK government published last month, and the role that it sets out for nature, there are 2 key roles described. The first is sequestration, and this is focused on planting trees. And I think all 4 governments have set ambitious targets to increase tree planting rates by 2030. So if we look at some of those numbers, in England there's plans to increase tree planting or treble tree planting rates, which roughly equates to 7,000 hectares a year until the end of the current parliament. In Wales, there's an aspiration of 100,000 hectares of new woodland by 2030. Here in Scotland, they currently aim to plant 12,000 hectares a year, with this increasing to 18,000 hectares a year by 2024-25. And in Northern Ireland, they plan to plant 18 million trees in the next decade. Now, the second role for nature set out in the net zero strategy is reducing emissions, and the focus shifts here from trees to mostly peatland restoration. So again, if we look at the numbers, England is aiming to restore approximately 280,000 hectares of peatlands by 2050, and Scotland is aiming for 250,000 hectares by 2030. So as you can see, the scale of the ambition and the nature's role in delivering net zero is large. And for a country as small as the UK, there's some pretty big numbers in hectareage. So I wanted to highlight 2 things. Nature-based solutions is also mentioned several times within the net zero strategy. But I think it's always a good idea to remind ourselves what we mean by nature-based solutions, and that an action or an activity is only considered a nature-based solution when it considers human well-being at its heart, in addition to biodiversity. And this, more often than not, includes local and indigenous communities. So therefore, many nature-based solutions can be considered a triple win, not just for biodiversity, but for climate and people. The diagram on my slide I've taken from a recent Natural England report that reviews the evidence of carbon storage and sequestration by habitat that can be commonly found across England. And I think it's interesting to note that not all solutions can be considered a nature-based solution. For example, if you look at nature recovery and species introduction, it is not considered a nature-based solution. Note perhaps the societal challenge that's missing from that. Of course, it's species dependent. But also note that not all tree planting is considered as a nature-based solution. So planting native woodland is in that middle part of that diagram, as is agroforestry. But non-native production forests, so tree crops, although they might help us achieve net zero targets, they probably won't give us the benefits we would expect for nature recovery. So by considering nature-based solutions as a tool in the net zero strategy to help mitigate against climate change, we're also recognising that while reducing emissions is key and important, the policies and actions we need to consider the implications on other services that the landscape provides. In particular, that they do not accelerate a further decrease in biodiversity. Benefits for carbon sequestration at low cost, but it can also result in biodiversity loss, greater water insecurity, and potential reductions in income from switching from agriculture to forest-based activities. So a focus on reforestation can also obscure the benefits from initially protecting intact ecosystems and forests, and can divert important resources away from those ecosystems that are potentially more efficient at carbon storage or sequestration. Given that we're discussing changing the way we use land, it's important for us to consider the impact not just within landscapes, but between landscapes across the world at various scales. For example, if we plant all those trees in the UK and improve those habitats, then we cannot do so at the risk of deforestation or changing land use elsewhere. At the policy level, this has been recognised in the DEFRA 25-year environment plan, where one of the key drivers is change in overseas environmental impacts is UK consumption of key commodities. So there is also a recognition of sustainable production and consumption in Wales's State of Natural Resources report, Scotland's 2020 Environment Strategy, Northern Ireland's Sustainable Development Strategy, as well as the National Food Strategy and the Dasgupta Review. So in response to this, on the 28th of October this year, JNCC released a new experimental statistic as an update to one of the UK biodiversity indicators. The statistic will act as an indication of the global environmental impacts of UK consumption, and it comes with an interactive dashboard that allows us to interrogate the information visually. This is the first of its kind in the world, and it measures the loss of biodiversity, the hectares of deforestation, and the scarcity-weighted water use associated with UK consumption, alongside a range of other impacts. So the example on the screen is tropical deforestation driven by UK consumption, broken down by the countries where those impacts are taking place. Currently, there's a limited range of commodities, but there are plans to add more in the future. So to summarise, we know that net zero recognises nature-based solutions as an important part of that toolkit needed to deliver net zero targets, and we know that nature can do more than mitigate against climate change, including adaptation and building resilient communities, but only if we act in response to the biodiversity emergency. And we know that it cannot be used as a solution in isolation, and it's most effective as part of an integrated solution with other approaches. There are some policy challenges that I'm hoping Ian will tackle in his talk. Some were mentioned in the NET strategy, so how do we spatially prioritise action at various scales, from local to national, and how do we then support those prioritisations with key decisions? But how do we also include all those dependencies, trade-offs, benefits within the decision-making? How do we engage with private finance? So carbon offsetting may be a valuable mechanism for planting trees, but that's unlikely to work for something like peatland restoration or other nature-based solutions. And lastly, how do we deal with the climate hazards, such as the increase in frequency of wildfires? If we plant all those trees and improve all that habitat only to lose it to fires, then that's not going to help us deliver our net zero targets. I think the one thing that was not mentioned in the strategy is the challenge of measuring progress against targets, and how do we continue to monitor progress over time. The global indicator I just mentioned may be one of those ways of doing that, but we need to do a lot more in that area. So to finish, I think we need to make sure that net zero drives sensible, multiple outcome decision making and avoids a carbon-only landscape. because that is likely to continue declines in biodiversity and impact multiple other benefits that we need as people from the landscape. Thank you.
Fabulous talk. Thank you very much, Gwa. Any immediate questions? Yes?
Thank you. Hi there, thank you, and thanks for the invitation to this event. I enjoyed the talk, and it makes me think of something that I'd heard about for the first time earlier this week, which is the net biodiversity gain element of an environment bill that's coming through. And I wonder, and the conversation that ensued when we spoke about that earlier this week, for me was some of the relationships that you've already mentioned in your talk. And I wonder if there's some intersections with this work and opportunity in terms of incentivizing both a certain kind of offset, perhaps, as well as a biodiversity gain. Thanks.
Yes, good question, and it is included in the Environment Bill that's currently with Parliament in the UK government. And I would say it is definitely considered, and it's possibly one of the, dare I say, the opportunities we've had from Brexit, the ability that we now get to change our land management systems and turn them into a more environmentally focused land management systems. And this is where the idea of net gain biodiversity has come from, and this is why it's currently included in the Environment Bill. Again, the policy challenges that I mentioned there, they're all still valid in those policies as well. But the fact that they're being considered together in an integrated solution, I think, is extremely positive. So hopefully the future is bright for our environmental land management, whether that's agriculture, but everything else we use in the landscape as well. So hopeful, I think, is the word. We'll see.
Grand. Thank you very much, Gwa. I really appreciate it. As I say, we're going to have more time for questions at the end, so please save them up. And if those watching online can just put them in the chat, that would be appreciated. So Gwa gave a fantastic introduction to what I'm going to be talking about now, which is how do we plant the right tree in the right place. In fact, I'm going to change it slightly. I actually think we need to almost go beyond the focus just on species, which is very, very important. But I think there's a lot of agreement with regard to the species question. I think we now need to also think about the issue of where we plant them. And more generally, what I want to talk about is how do we bring all this climate and biodiversity science into decision making in government and in the private sector. Okay, so, and I'm going to start with this little saying from the philosopher Mencken, which is that for every complex problem, there is an answer that is clear and simple and wrong. And unfortunately, we've had a lot of clear, simple and incorrect answers to complex questions for a very long time. Let's look at a complex problem. What's happened over the last 120 years? We've seen from the previous graphs what's happened to the environment. But we need to also think that there's other things happening as well. So, for example, the last 120 years has seen a massive global improvement in life expectancy and in incomes. And we would almost be certainly ignored if we fail to make that connection. We want to influence decision makers who, yes, they are now beginning to listen with regard to climate and biodiversity, but this is the sort of thing they've been listening to for the last 200 years. And if we forget that, we will get ignored. This is the other side of that complex problem. The fact that we are seeing unprecedented speeds of climate change. So that's what really scares me. It's we're looking, all the focus often is on the absolute level, and it is really scary. But the speed is potentially the fastest that has ever been seen, not just in human history, but possibly on the planet. Certainly in terms of temperature rises, we're looking at a change which is unprecedented. And we're seeing a loss in biodiversity which has only ever been seen before at the ends of geological eras. Okay? And even then it didn't happen as fast as it's happening now. So things are really moving in the wrong direction and at a speed which I personally don't think human society is anywhere near coping with. And we need to address that really fast. And we've seen natural capital being eroded as produce capital is increased. So, complex problem. What's the simple solution? Just plant some trees. Well, unfortunately, that simple solution is nowhere near as simple as it sounds. It's actually a complex solution, one where we need to think about the variety of uses with which our land is put to. And if we just focus on one, we will end up getting ignored again. We've got to think about more sophisticated answers. So, for example, take our land use. Think about the choice between farming and forestry. Well, first of all, we need to recognise that land use is not random, particularly in a country like the UK. In fact, I would say there's no natural land really left here. It's the product of at least three big drivers. Policy, markets, so how much things cost, how much they can be sold for, and the natural environment. And that natural environment is spatial, varies enormously between places, and sadly, it's now varying over time as well. And that land use provides lots of different values. And the ones that are typically dominant in determining land use are those ones that come out in markets. But there's a load of other values that we need to consider in here as well. Things like water, recreation, health, greenhouse gases and biodiversity. We need a decision-making system that brings all of this into the decision, not just the bit above the dotted line. How are we going to do that? Well, there is a practical challenge here. All this stuff up here turns up with pound signs in front of it. All this stuff down here doesn't. And it tends to be treated as if it's just invisible. It actually comes up in all these different values. Now, there are many different views on how to do this, but the one I'm going to be arguing for is that as far as we can, and I'm going to argue we can do this a lot, we should actually value those things we can value. And as I hope to prove to you, we can actually do a fairly... Just go with me about that. I mean, just a little one, what actually is the value of continued existence of a future, another species? There's lots of good arguments for not doing this. So what I'm going to be arguing for is value what you can value robustly, and for that you can't, use, I think, pretty simple, very cast-iron approaches, like simply saying, this is similar to the question we just had, let's stop the losses. Don't do anything which is going to make the loss in biodiversity any worse. Basically, if an investment's going to do that, you've got to do a different investment. So, let's look at how we can bring all of this into decision making. Well, firstly, we're really lucky in this country. We've got fabulous data. We can actually understand those three big drivers of land use, physical environment, markets, that sort of stuff. Millions and millions of data points available. Therefore, we can actually produce an understanding of this, commonly called modelling. And those models are really good now. So these are predictions from the model, and this is what actually happens. And you can see, we can predict things really well now. And because of that, just like we can predict futures for climate, for example, we can see what the consequence of those changes would be for land use. If we did nothing else, if we don't act on policy, what's going to happen? Okay, so this is, roughly speaking, land use in Great Britain at the moment. I'm really just showing two land uses here. There's obviously loads and loads of them, but I'm showing beef production and cereal production. And because things, as Richard has said, are going to be that we're getting a drier environment and a warmer environment on average into the future, what we're actually going to see is more and more land in this country actually going into cereal production. Why? Well, because it becomes more viable as things warm up, and also because it's more profitable. Okay, so you can't actually understand what's going to happen unless you bring in the economics alongside the science. Now, that's going to cause a lot of other changes. For example, it's going to really change the loading from agriculture into the waterways. Going to get a lot more water pollution. That's going to change water chemistry. That's going to change the ecology. And it's not just in the water that we're going to see this change. We're going to see the change terrestrially as well. How do we then bring that into decision making? Well, some of it's already done for us. We can find out values for things like treating water in the future when it's more polluted through markets. But what about non-market values? I just want to take one example and then I'm going to push on. I'm going to start with a really, well, I think easy one. Valuing recreation. How on earth can you value outdoor recreation? Well, actually, you just look at people's behaviour. We've got fabulous data on where people live, where they go to, the sort of routes they take, how often they visit. We can link that to the quality of the environment at these different sites that we go to and analyse this. And when we do analyse it, we find very logical, and this is where, my mum says what they actually pay you to do this. Yes, we find that people prefer to go to cleaner, less polluted sites than dirtier sites. And we can actually look at people's decisions and how that is reflected in the costs they pay, and therefore work out what it must have been worth to them. Then these people aren't crazy. They're doing it because they'd rather go to a less polluted site than a more polluted site. Okay, so we actually have values that come out of what people do. And these give us some very interesting observations. One is that actually the most valuable places for recreation are near to where people live. They're not actually the national parks and that sort of stuff. Nothing against national parks, they're great. But actually improving the environment near to where people live is the thing that's going to give them the most value, the most well-being in their lives. Okay, let's look at other things that we can bring in. We can apply this same sort of way of looking at the world to, let's say, how trees are going to grow. Okay, trees are also going to respond to the fact it's getting warmer and drier and that sort of stuff. And what we're going to find, now, if you look at these horizontally, just look at them for a bit, you'll actually begin to detect differences. You'll actually detect that as it gets warmer and drier, conifers are going to grow less well. And species like oak are going to grow better. Now, you might think, that's not huge. I mean, okay, the conifers are being shifted off. But this is just in 50 years, which, in geological terms, this is like that. This is so fast. We are literally making it impossible for some species to exist in this country. Now, you might say, well, that's great because I don't like Sitka spruce, okay, but I'd agree with you. But nevertheless, it actually shows just how dramatic the impact is on our environment. Okay, when we change land use, we change, actually, I'm just going to go back a bit. We change greenhouse gas emissions from that land use. And we've already heard, I think it was Guar and Rich talk about this. And we change it dramatically in lots and lots of different ways. We change it because we grow trees and they store carbon, that sort of stuff. But those trees, they alter the soils underneath them and store carbon in the soils. If, for example, we're changing the number of cows, that's going to have huge impacts on our methane emissions. What about diets? And this is an interesting one because if we if we decide that we're going to plant trees all over Britain, which actually, I've got some sympathy with doing that. I love trees. I think it's best use of the land. But if we do that, we will start importing a lot of our goods from overseas. And if we start, for example, importing meat from Amazonia, we will be contributing to more emissions than if we'd never planted those trees. This is an unfortunate truth that we have to face so that we don't actually make things worse by actually doing something that looks like a good thing. Here's an example of a simple solution that could easily go wrong if we don't plan it. Okay, but generally, the move from agriculture to more forestry, not complete forestry, would be good in terms of greenhouse gases, as long as you don't plant on areas like peat, which actually would give you global warming forests. Okay, and we also need to think about what we're going to do with this timber later on, because if we just grow species that end up as cardboard boxes, well, all that carbon's going to be out in the atmosphere again really, really fast. Okay, the last one before I bring it together. Biodiversity. So all the stuff that I talked about before are things where I believe we can come up with robust values for those elements. Here's something I don't think we can come up with robust values, but what we can do is model the relationship between land use change and measures of biodiversity, like the sort that Gua was talking about. And we can do this pretty well. We can do it for lots and lots of different types of taxonomic groups. And the results are fairly scary. This, by the way, is work from JNCC, best conservation organisation in this hemisphere, as far as I'm concerned. So you can see the sort of messages that are coming out of this. Red is not a good colour for any species to be flagged in. We can bring all this together into tools, decision support tools for decision makers like government. And we've actually been working with DEFRA for, can't remember now, about 7-8 years. So they've actually got access to this. This is a tool that anybody can access. It was led by Professor Brett Day at LEAP, the organisation that I work with. And it's an amazing tool which allows you to look at any area across the country, any scale you want. You can look at grids, you can look at natural units, that sort of stuff. And there you can look at all the different types of well-being and value streams that you get out of land use, ranging from financial to these wider values that are generated. So, here we've got something looking at agriculture, looking at water quality. I want to finish with one example. And it's an example that we ran for the government a few... and I just hope that this is going to actually help guide what they do. So we were asked to look at planting Britain's new forests. And the level of planting is actually the level that is being considered at the moment, so 750,000 hectares. And we said, yeah, we're happy to do this. We're actually going to do it twice for you. First of all, we're going to show you what's going to happen if you do the usual thing of just taking a heap of money and throwing it on the table. And anybody can apply for it. Okay? Well, if you do that, what factors are going to determine who plants and where? Well, obviously the size of subsidy has an effect, but the main one is how much am I, as a landowner, a farmer, that sort of stuff, going to lose by planting trees? Okay, subsidies is the main benefit. There's a little bit of timber, but that's a long way ahead. I'm not really very bothered about that, but the cost is mainly going to be my foregone food production. And so what you're going to find is that the planting occurs in places of very, very marginal agriculture, very low value agriculture. A problem with these areas, a lot of them are high carbon soils, so you know they might not necessarily be peat, but they're still high carbon. You put the trees on, and actually quite a lot of carbon starts getting leaked back into the atmosphere because they dry the land out. Not particularly great, some of these for biodiversity. They're quite precious conservation areas. Not helping flooding. You can see these are areas where not many people live, so there's not much in the way of recreation. When you add up all those benefits, you find that it's actually not even worth doing this. The benefits are not as big as the costs of doing this. And I really am saying here, we would better not to plant those trees than to do it like this. And remember, this is the way we normally do things. So instead, use this alternative approach. I haven't used the term natural capital before because I think it puts people off, but it is called the natural capital approach. And I'm very pleased to say that we've worked with the Treasury, and actually this is now their preferred approach for doing this. And that is to look at all the impacts that this is going to have. For those things that you think you can robustly value them. Absolutely fine. Let's value the environment. We haven't done for the last 200 years, and look where it's got us. For those things we can't value, apply this no-loss rule. You're not allowed to do this where you're going to actually damage biodiversity. Rule some places out. Do we end up planting in the same place? Absolutely not. We're planting very different places. We're not planting on any peat soils now. We're planting in areas that are, at worst, neutral for biodiversity. Actually, it turns out most of these places are quite good for biodiversity. They're good for water quality. You can see there's a lot more now around where people live. And that's because it's generating recreation values. What is the balance of benefits and costs that come out of this, even when we're not valuing biodiversity, we're just making sure it's not negative, massively positive. Suddenly you get a result which we all kind of know, that if we put these things in the right place, planting trees is a really good idea. So we can move from this to saying that for every complex problem, there is an answer that is clear, correct, and impactful. Thanks very much. Thank you. Apologies to my timekeeper, because I ran over appallingly. Right, what we're going to do now is have a panel session, so if you can sort of grab your chairs and come around, and I will MC it, and we will pass the questions as appropriately as possible around each other. And remember, if you're on whatever it is, Facebook, Twitter, Flickr, whatever, COVID app site, you can send questions in through the mysteries of the internet. Any questions? Oh, yes, right. I've got to pass this over to you because otherwise the people online won't hear it. Can I ask, actually, if you could just introduce yourself?
Hello, I'm Julia Denham. I work for BT and I've done 2 Exeter degrees, so that's nice. One biology and one business, woohoo. Thank you, Ian, that was really interesting, and I think over the last week I've been particularly in the land use and biodiversity bit, I've been really struck by most people don't get it. They don't even get this problem of putting a tree in the right place. But you've found a data solution that's worked. I was interested in how scalable that was, particularly in light of the vast amount of finance that is about to go into carbon offsetting projects and planting trees in lots of random places.
I'm going to start off just talking about it. So scale is something that we're very, very aware of. There's no point producing an answer that can only be used at sort of a nation level. Well, I'm not saying there's no point, but certainly that's no help to a farmer, that sort of stuff. So the system that I've just shown you there, at the moment, you can sort of get it down to pretty near to a farm level. But what we will be able to hit within the next 2 years is field level. And then it suddenly becomes relevant, not just as a planning tool for DEFRA, which we're already there, really, but a planning tool for somebody who owns and operates land. With regard to expanding outside the UK, so one thing I want to say is, the answer is as good as the data you've got, and we should always respect that. But generally, I would say that, first of all, as long as we remember, and this is a general thing for interdisciplinary science, we are not trying to produce the perfect answer that 10, 15, 20 years of, nice disciplinary research will give you. You can do that, and you'll be able to answer maybe one tight question, like what's the impact on nitrates or something like that, really, really well. But that's no help to a decision maker who's got to think about hundreds of different variables. What we're trying to do here is not produce perfect answers, it's produce better answers. And they will iterate and be better as time goes on. Okay, Alice, is that all right?
Yeah, I mean, I guess it links to kind of a general point that I would raise around timeframes and scalability of lots of different solutions. So I'm not at all an expert on the land use side at all. But one of the things that has come out in another project that I was part of on the water, food, energy nexus is this issue about context being really key to some of the solutions that we come up with in relation to reducing emissions, and that doesn't even touch on the kind of the biodiversity side of it. And so this context specificity, it's really interesting hearing what you've been talking about here, because it's so important here as well. It's that the sort of idealized solutions that we can imagine and we can kind of project in climate models and integrated assessment models and so on. They are idealized solutions, and we know that in some areas we might get more bang for our buck, if you like, but in other areas actually maybe not. And they don't necessarily balance, and we do tend to be quite optimistic when we're talking about upscaling. And working in a school of engineering myself, in terms of any sort of large scale infrastructure project, whether it's a sort of hard infrastructure or whether it's more land use and nature based infrastructure, there are always things that slow it down and always things that make it more challenging to actually deliver in practice. And asking the right questions, putting the right factors in at the start is absolutely key. But I think that just recognising that any delay has an impact, the timeline matters. And so, I do think that questioning when we see big numbers, when we're seeing this upscaling, we just need to question, has the context, has the specificity been considered, have we asked the right questions in the first place? And therefore, if we're being a bit too optimistic, we just need to make sure that's communicated so that we know what the risks are.
I'm actually going to go to the gent here because you got in earlier.
Yeah.
Thanks, Ian. Colin Galbraith, Chairman of JNCC. Thanks for the invitation and thanks for the series of wonderful talks. A question for Ian and then one brief one for the Met Office, if I can. How do you build in the wider public benefit, Ian, into what you've done? I mean, it's economics, we've got biodiversity, but how do you assess the public interest in terms of wider benefit? And then the very simple one for Met Office is the heat maps were really interesting. How could they inform government policy in terms of overseas aid? Could we target areas that are going to be worst affected now so that we can maximise the benefit and head off some of that? Because you had various levels of heat coming through to the heat stress end. So two completely different questions. Thank you.
Thank you very much, Colin. So I obviously I'll take the first and then I'll pass over to Rich. So the wider benefits. First of all, the reason why I took a little bit of time to explain the recreation one, you might have been surprised for me choosing that one rather than starting with carbon, say, is because what I wanted to convey is that the values that go into this are not my values. They are not values that have actually been, for example, calculated in some lab. They are the values associated with people's behaviour and what they're actually doing. There are difficulties and limits when you're trying to extrapolate from that to different environments in the future. So, for example, what will people's preferences and decisions about food consumption be like in 10, 20 years' time when perhaps awareness of the consequences of different food choices will be even higher than it is now? Also, how do they change when, for example, policymakers come in and try and nudge that behaviour in a certain direction, maybe through fairly traditional old-style taxes, that sort of stuff, or through information or even the presentation of different choices. What I'd say is that what we're trying to do always is not trying to impose our values, but to try and discover what values are actually out there. But this is also why we don't try and value biodiversity, for example, because if I was to ask any of you, well, so how much for the goldfinch? How much for the striped shiner, for example? Okay. Fabulous creature, the striped shiner. As you know, it is a bird fish. You can ask people questions about things that don't actually exist, and they will sadly give you answers. So only ask sensible questions that people can reasonably answer. Okay.
Yeah, thank you. So you're asking about the using the heat stress maps I was showing for. Well, you said international aid, I think was the phrase you used, or it was international development.
Yeah, that's right. I can see a real relevance to what UK, and not just UK, but other countries could do now to begin to really target those areas that are likely to be most effective.
So I guess it depends on what kind of timescales we're looking at. The loss and damage agenda is very important, and there's a lot more happening this year and previous COPs, and it gets higher and higher up the agenda. I guess this would be so that relates to helping countries deal with the climate change, which has kind of been imposed on them by the failure to act earlier and sooner. This would clearly be one factor which would be taken into account there. There's many others as well, sea level rise and so on. And you probably wouldn't want to take into account just the climate factors as well. But it certainly could be one part of that. That's kind of in the longer term, I guess. But also, this kind of thing could be thought about as for climate change adaptation in the nearer term, in a kind of more responsive way. If we can have that sort of nearer term predictions on sort of seasonal to interannual timescales to see ahead when there's going to be a severe event coming. We're probably not there yet, but this kind of thing could help with climate change adaptation. If we can see there's going to be a very, very hot season coming, then we can get things in place to help there as well. So that's something else to aspire to, I think, on the science side.
Hi, sorry, my name's James Hutton Mills. I'm an Exeter alumnus. I build large-scale renewable projects in Africa specifically. A broad question to the panelists. I think, in my opinion, one of the successes of COP this year, COP26, is that, to me, there's been an acceptance of science, an acceptance of the brute fact that carbon is going in the wrong direction. But the acceptance of that is something that wasn't there 10 years ago or 20 years ago across the board. So, but I think a second theme that's perhaps come out is the fact that the pushback country by country is from those emerging countries where their GDP per capita is lower than they'd like it to be, and where they would argue that they aren't big emitters. So I just want to ask the panelists how they think their research going forward can evolve to incorporate that type of theme.
So given it's Nature Day at COP26 today, I think I will also say that one of the successes of this COP is the fact that nature has featured so prominently in the first week, at least, in numerous events and discussions. So it's not just about climate, but I don't know if there's acceptance yet that we're also facing a biodiversity emergency. But the fact that they're, both being discussed at a climate conference is at least making some progress on that conversation. So in terms of the science, a better integrated approaches, I think, as this session has demonstrated, I think it's been really interesting to hear the perspectives of all the different fields and to bring experts in those fields together, and I think more of these conversations is what we need to have, and then hopefully, you know, the science will evolve from these sorts of conversations, because traditionally these fields don't talk to each other. So, you know, the science doesn't exist because we're in our own silos. So hopefully, you know, now that there's an acceptance that nature and climate, they're interconnected at all levels, then a new perhaps science can come from this as well.
Yeah. So, in terms of big emitting countries, you know, one of the things that hopefully, I mean, as I say, I haven't been at the last few days of COP, so I haven't heard it directly, is recognised is that, you know, a big emitter country, it could be just because it's made up of a very large number of people, but with very low per capita emissions. And in terms of sort of incorporating what that means from an economic point of view, I think it's just very important not to just look at things like GDP growth when looking at development, looking at emission growth in countries with low per capita emissions. That being important from a kind of like development perspective, other development indicators are also key. And if we, you know, one of the things that I would like to see more of, and, you know, I'd like to expand our research, if you like, to kind of incorporate more of, is how we kind of unpack that term growth in terms of development, in wealthy countries and development in developing countries, if that is the right term, which I don't think it probably is. So in other words, there's a kind of an increase in income in a rich country that doesn't necessarily make a difference to the average, you know, in terms of the wealth of that particular country. In wealth, when I talk about wealth, meaning, you know, how standards of living, life expectancy, education, and so on and so forth. But that might be absolutely crucial in another country where it's at a lower development, on the lower part of the development curve. And if we just kind of focus on the GDP growth being like a good thing per se, then we lose track of the fact that that's going to lead to an increase in emissions in wealthier countries, whilst it might be a good thing from a developing country perspective, but not necessarily going to, we don't want the transition to involve stakes, I guess, as some of the wealthier countries have made in terms of emissions and energy system development and so on. So just unpacking that kind of economic debate a bit more, looking at some of the other indicators that illustrate, you know, benefit to society, but without increasing emissions, because we're so, you know, trapped still with the GDP growth and emissions. Breaking that is a real challenge, and maybe part of it is looking at some of the other indicators that matter in terms of you know, life expectancy, health, well-being, seeing friends and family, that kind of thing. So, you know, and I'd like to hear perhaps a bit more from Ian and others on if you know any more about that.
Well, okay, if you don't mind, something that really did trigger with me. So I have been extremely lucky, and it is mainly luck. In that I've made some sort of fairly random choices in life that have managed to find me in a position where I spend most of my time working with absolutely fascinating people, like the panel here. People from different disciplines who are interested in actually combining together and recognising that only by doing that we will be able to address the complexity of problems and challenges that are addressing the world. I think we're making real progress here, but we've still got a huge way to go, and I still think we're rather limited in our conception of an integrated approach. So, you know, I've been working with people like Rich for a fair while. Well, ever since I went to Exeter. So you can see economics and climate change, and then we've got people like Gua on the ecology side. And increasingly, we're seeing more connections, say, with Alice and the engineering side. But there's still more to do here, and it's not just badge engineering of adding things on. This is really important. If we don't start connecting in ways to society and people, and understanding that people generally have no concept or connection, there's certainly no emotional connection with a lot of the arguments that researchers make, then we are really playing with fire. We're taking a huge risk on just hoping that the people in charge actually do listen to us and do act on this information. Sometimes, and we've seen that with, the previous 4 years in the USA, that isn't how it works out. So we actually need to understand better the connection to individuals and society, and actually try and connect in a way that is meaningful to them. Because that's actually, I think, a very important additional route to delivering the sustainable world that we want, and more equal world that we want. Okay, I'm going to actually... sorry, Rich, I'm just going to try and get some more questions in, because I think there were more. There's a lady over here. Oh, there's lots. Okay, I actually think that the gent at the back was the first one to stick his hand up, but I'm going to try and get to both the other questions.
Thank you. I actually had two questions. I'll try and condense it into one.
Right.
So I'm Peter Stott. I'm a climate scientist from the University of Exeter, actually, and also the Met Office, colleague of all of you, really. So I think, just responding to the previous gentleman's point, I agree with him that COP26, the policymakers have for sure accepted the science. I'm not totally convinced they've accepted the urgency of that science. So relating, I guess, to Alice's perspective, which is really interesting, of course, I attended a session this morning in the Science Pavilion, which was about the oceans and cryosphere, where I learnt about the ocean dialogue. And so this picture of the overall budget of, the area under the curve you talked about, of course, applies to temperature. But, of course, with sea level, we're talking about irreversible changes and things that, are not going to be reversible. So the longer that we stay above a certain temperature level, the longer we lock in these irreversible changes. So trying to get to a question and trying to relate it to the economics, which is something I don't know anything about. How do we... to do an analogy with your example of some things you can value and some things you can't. So, of course, the thing about sea level is that we potentially put whole people and whole nations at peril. How do we possibly value that more broadly? Or is that one of your categories that we say we can't value it, and therefore we have to just not do it?
Turn myself off, sorry. Economists talk about two types of value, marginal values and non-marginal values. Marginal values are, the price of beans gone down, I'll buy some more beans. That's absolutely great. And in a way, that sort of approach actually gets you quite a long way down the road. For example, it allows you to do things like changes in the amount of nutrients in water. Okay, that's something we can deal with within limits. What you can't deal with, what becomes non-marginal, is when there isn't any water. And the same thing applies to flooding. So sea level moves from here to here, and you live in, let's suppose we live in Devon. Actually makes almost no difference whatsoever, actually. We've got these 200-foot cliffs. Well, that's fine. You live in the Maldives, that is a non-marginal change. Okay, and we then have to think about: are we going to ignore non-marginal changes because they're not happening to us? Now, the economics actually is fairly clear on that, but the economics, I'd say sadly, doesn't always make the decisions. Economists actually are there to provide advice to decision makers. Why? Well, there's two reasons. One is they're not the elected representatives. And two is our advice, even when it's better than advice that we gave in the past, will never be perfect. It will never be comprehensive. And I'm okay with admitting that. I know economists that aren't. But that is the fact of it. When you're looking at non-marginal changes, like you're going to lose this entire... I took some from the Marshall Islands, It actually then becomes a moral and political issue about whether we're actually going to save that community and society or not. I can say this is a non-marginal change. I've said it with regard to biodiversity. Well, that's for two reasons. It's non-marginal and it's very difficult to measure. But we have to stop eroding biodiversity. I personally think we have to stop destroying island states like that. Right, I'm going to bring in another question. If I can just... Actually, yeah.
Hi, my name is Ananda. I had done my Masters in Climate Change and Finance from Imperial College and currently doing the Exeter MBA. Just regards the right place to plant the right tree, you showed the natural capital way which is being implemented by the British government. Is it being taken up by any other organizations like the UN to evaluate the impact of their RED Plus programs and like encourage agroforestry in the tropical belt? I mean, is there any research on that, any evidence worth sharing that can encourage planting right trees at the right scale at the right place? Second question is that with regards to biodiversity and permafrost, which figures I don't think any of the projections have taken into effect. Has there been any current research which links the two, like introduction of bovine species to slow down the thawing of the permafrost or something which is being looked into by your organization? Yeah, these two.
Okay, I'll answer the first one. The second one sounds really complicated, so I'm going to ask somebody else to answer that one. The answer is yes, but imperfectly, as you'd expect. So the United Nations have actually been quite a leader in this area. Particularly, actually, there's two types of analysis that economists do with regard to the environment. There's the sort of thing I showed you here. You can almost imagine that as a version of investment appraisal. You know, you've got something that you're going to do. Where's the best place to put it? That sort of stuff. There's a much higher level question, which is, in which direction is your economy going, and is it sustainable overall? And that's an area to do with what's called natural capital accounting, and it's much more about the recognition that the measures that we have at the very highest level are inadequate. So the one that everybody is probably familiar with is gross domestic product, GDP. What that tells you about is the amount of money that's circulating around in the economy. And that actually is not an irrelevant issue. It tells you about jobs, that sort of stuff. But it's not sufficient. And it's not sufficient because you can increase GDP by running down the environment. So you have to have a second measure alongside it of what's actually happening, not just to our economic stocks, but to our stocks of nature as well. And that's where you get this term natural capital, which is not one I'm massively keen on, but you know, it is technically correct. And the UN have really pioneered the development of this second measure. With regard to the sort of stuff I do, which is sort of, I recognise, subservient to that, how do we actually choose between projects? It is growing. It's much more common now across Europe. Actually, if it wasn't for the political environment, you'd have seen a lot more of it going on in America over the last few years. I think you're going to see a lot more from now on. Okay, I'm going to pass on, and this will probably be the last answer. Yeah.
Yes, you're asking about permafrost, and so you said it's not included in the climate models. Actually, it is starting to be. So some aspects of the permafrost thawing and feedbacks are now included in the Earth system models, but it's a lot more complex than we currently represent it. So it's clear that a lot more needs to be done. So just to clarify your question, were you asking, is there any research on slowing permafrost thawing through other means, through land use change and so on,
as well as biodiversity introduction or reintroduction, for example?
So I'm not actually sure. That's a really good question. I'm going to guess that there's not much that could be done other than don't make the climate warmer. But if anyone has any better answers than that, I'd be really happy to hear that.
So I would agree with that. I think
do not make the climate warmer is the only answer. I don't think introducing any management action to prevent any sort of ill effects might work. I think what we'll have to do is adapt, because it's going to happen, and this is where biodiversity is probably going to be an ally, because we know that the more biodiverse our landscapes are, then the more likely they are to adapt to any changes in the landscape, and the quicker they will do so. So if there are any nature transformation programs happening in those places where the thawing of permafrost is happening quickest, then those places are likely to become more resilient to those changes in the future. So I think that's probably the action, the adaptation that needs to happen, as opposed to prevention or mitigation.
Thank you. We have unfortunately run out of time. I want to ask you to welcome my boss and tell her how much you've enjoyed this, and it was actually the best part of COP. So I'm going to hand over to Professor Alex Gabasi from the Business School at Exeter.
Thank you. Thank you, everyone. I just want to thank you for attending today. I'm really delighted to see so many knowledgeable and talented people who are passionate about tackling the climate crisis. I want to give a thank you to Gail and the entire Arctic Base team for hosting this event, and of course to Ian, Richard, Alice, and Gwar. Thank you also for sitting in the exact order that it is in my notes. Thank you for their stimulating and informative workshop today. So I want to start by pretending I'm cool, which I'm not, but I'm going to make a reference to popular culture. I know you are all really, really busy people, but has anybody watched Squid Game? Okay, I'm getting some nods. Okay, it's the most popular content on Netflix right now, and if you don't know, it's a Korean drama that involves contestants participating in games to win a huge amount of money. Sounds cool, right? So you're wondering why I'm talking about this, I'm sure, except for the two people in the room who are not wondering why. We asked some of our business school students if they could find a way of engaging other students that highlight what we're doing here at COP26 and to educate others on the key issues related to climate change. So the students, Luke, wave Luke, and Sophie, wave, came back and pitched climate games, and they wanted to stage a series of games based on the series. Oh, cool. I don't know. That was pretty cool. I'm going to quote part of their pitch. Inspired by the Squid Game, these games will be a lure. All right, now we're luring students into a space where we can educate them about key climate facts as well as solutions and what the business school is doing for climate action. This sounds amazing. It's fantastic. Because clearly I haven't seen Squid Game. No, not at all. It turns out, in case you don't know, that the contestants get brutally murdered if they don't win. Huh. But then I thought about it. Okay, life and death. Isn't this exactly what's at stake here? So I thought if we can't associate our climate change education with this brutal life and death series, but then I thought this is exactly what's going on. So we might feel slightly removed as we talk about sustainable finance, natural capital, and biodiversity economics and circular economy. Those are things we do in the business school. But the truth is, the impact of our work has real implications for the future of our planet and our species. Life and death. It is that important. As the Deputy Pro-Vice Chancellor of the Business School, and Ian's boss, and Gail's boss actually too, I'm immensely proud of our work on NetZeroPlus and other initiatives. We have hugely talented people who are working across disciplines on policy change and business practice, tackling challenges like the climate change and biodiversity loss. But without sounding cliched, which I'm usually pretty good at, I'm equally proud of the student-led activity and the passion of people like Luke and Sophie and their creativity in communicating the challenges facing our planet. I'm also incredibly proud of the fact they undertook a health and safety risk assessment for their games, which is something that clearly did not happen in the Squid Game series. And, we take those things very seriously in the business school. Now, That's it. That's it for me. I'm going to pass over to Gail, but I do hope you take the opportunity to meet us afterwards inside the bigger tent for a reception, and we can continue to have our conversation. So, Gail, over to you.
Well, thank you, everybody. I'm Gail Whiteman, and Professor of Sustainability at the University of Exeter Business School. Now, many of you have met me kind of by Zoom, but this is really what I look like in person. And this is Arctic Base Camp. So this is a science outreach not-for-profit that I founded and is something that we take to the World Economic Forum at Davos every year. We bring in Arctic scientists and climate scientists. We camp at Davos in this and in smaller tents. And we brief a variety of different people, including world leaders. We had Greta and her father camp with us. We've had Rainn Wilson, the U.S. actor, who's on my board, camp with us. We've had other youth. We've had scientists. And we've had a fair amount of media attention and some influence in changing the narrative of the Arctic melting as an economic opportunity, which I think is what the UK Prime Minister also said sometime this week, and actually changing the dynamic, at least at Davos, into the idea that it's actually bad news for the economy and society because of the way it can amplify climate change, and of course that affects all of us and how we do our job. So I'm just delighted to have you here, host you at Arctic Base Camp. I've never seen so many suits in Arctic Base Camp, so that's a good thing, which means that clearly the brains and the money are in the good commitments on some groups looking at reforestation, the oceans, ending coal, but it's not enough. Let's not kid ourselves. And one of the ways we tried to emphasize that was we actually brought an iceberg from Greenland, which is sitting outside covered up because of the torrential rain that has been happening, especially today. And that's not unusual for this iceberg because Greenland saw so much rain throughout the whole summit this year, and that's never been recorded in the past. I just had a text, Ian, while you were wrapping up, from one of our colleagues who used to be our chief science officer at Arctic Base Camp. He's now in Cambridge Bay, and he's works for Polar Knowledge Canada. And he said that the data's in, and the past month has continued the record-breaking heat wave in the high Arctic islands. So they're in beyond code red. They're almost code dark red, code burgundy. I don't know how you go farther on that. And I think that's something that we have to remind all of us. We have to remind the heads of all governments, companies, universities that this is real, it's happening now, and it's up to us and them to fix it. So thank you for coming to Base Camp. I hope University of Exeter's first time at Base Camp won't be the last time. I hope to see you in Davos.